Warning: this video contains clips and excerpts of a humorous nature not normally found in math class. These are intended to fight the adolescent condition known as short attention span, found heavily in the modern teen, especially when in school. The only thing you should attempt at home is the math. The rest, you just laugh at. Hi, welcome to AT Math. Today, we're covering 4-6 arithmetic sequences. Why this will be easier than moving most large furniture.
I should tell you.
And we're back. First, we're going to talk about what a sequence is. If you remember, a sequence is just a pattern. And a term is each number in that pattern. Now, you can also follow along on page 272 to help you. Well, to measure how far you are from lightning by counting how long it takes from the time you see lightning until you hear the thunder. So if you see lightning outside, and then it takes a second or two to hear the boom, you can actually count how many seconds it takes for the boom to get to you, and that'll tell you how far away the lightning is. So, take a look. If you hear the lightning, if you see the lightning, and then hear the boom in 1 second, it's 0.2 miles away. If it takes 2 seconds, if you count off 2 seconds, it's 0.4 miles away. 3 seconds is 0.6, and so on. Now, the reason why that works is we have the speed of sound, which is really fast, like 700-800 feet per second, and so it doesn't take long for it to get to you. And we have here, though, notice how it's consistent. Every second is another 0.2 miles. Since these are the same every time, it's called an arithmetic sequence because we're always moving by the same amount. Now, because it's the same amount every time, 0.2 in this case is what's called the common difference. Oh, gotta take a doggy petting break. So you can see this is my dog. Oh, my other silly dog. Oh, and they like to fight a lot. They have lean right, I tell you. It's a dog's life, at least for them. Alright. Well, Gaki pet the dog's head for a second. He's like, no, pet me, pet me. Well, I can't pet you. I must teach math. I don't have time for a silly dog right now. Look, he's putting his paw up. He'll have to die. He's 95. Little dog. Anyway, enough with the dog. So, now, the number does not always have to go up. Now, if you remember what I'm talking about here, remember how I went up 0.2 each time. This time, let's say that the number's going down on something. Let's say I have so many seats, I'm trying to fill, and each week I have less and less seats. So week 1 I have 200, week 2 I have 174, week 3 I have 148. Quiet! Notice how I'm going down 26 each time. So it is still a steady decrease. So in this case we see the number going down each time at the same rate, so it's still an arithmetic sequence. Now, wait, is that all I had? Okay. Now this is the same, but we're going to write it different. 0.2, 0.4, 0.6, 0.8, and 1.0 is still increasing by 0.2 each time. Alright. Now based on this pattern, what are going to be the next three numbers? Well, if I know I'm adding my 0.2 each time, so I'll just add another 0.2, add another 0.2, add another 0.2. And a little trick I use is I just look at it as 2, 4, 6, 8, 10, so that's easy, 12, 14, 16, but it's going to be with the decimal inside it, so 1.2, 1.4, 1.6, as you see down here. Let's take a quick commercial, and we're back. Now let's do a U-try here. Now, this actually was my second try. For some reason, my program had fried on me, so I have to do this lesson over, so that's why I have things up here still. So let's go ahead and give it a try now. Based on this pattern, what would be the next three terms? So I have 3, 7, and 11. What's your prediction? Well, I hope you see that I added 4 each time. Added 4, added 4. So the next 4 is going to be 15, next 4 is going to be 19, next 4 is going to be 23. Pretty easy so far. I'll give you that. Now, this one here is a sequence, but it's not an arithmetic one. Notice how you have 1, 3, 9, 27, 81. Well, it's multiplying by 3 each time. Well, that's okay, but since we're not adding or subtracting, it's not specifically an arithmetic sequence. So we're not going to deal with it this time. And the reason why it's not an arithmetic sequence is because if you look at the adding, we're not adding by the same amount every time. So is this a sequence? Sure. Is it an arithmetic one? No. Maybe it's exponential. I'm not sure at the moment, but we can only deal with one thing at a time. Now, enough of the fluffy stuff. All that fluffy stuff is over. So too bad, Fluffy. Well, you've had your time, Fluff. Now we get to the hard work. Let's take 2, 4, 6 again. Now, we all know the next three numbers after 2, 4, 6 are going to be 8, 10, and 12. That's not a big deal. However, we're going to talk about the first number given is term 1, second's term 2, third is term 3, fourth is term 4, and etc. So you have all these different terms. That's what we want to do is we want to label each one. So term 1 was 2, term 2 was 4, term 3 was 6, etc. Well, you really need to write this down, this formula here. And you really ought to write this down. And of course, remember that if you write them down and turn them into me, you can go ahead and get 10 extra points, extra credit. But I would write this down as well and keep it for tomorrow's homework, for you will see this again. But basically what it's saying is that the first term, the first number, was a to the first. The common difference, in other words, how much I'm adding or subtracting each time, is the d here. Then you go ahead and you take the number that you need to go to, how many spaces you have to jump, minus 1 because you already have your first space, which all this together will give you your total. Seems confusing, but we'll walk through it a few times. Take a look. Let's go ahead and say that I'm going 5, 2, -1, -4. The question is, what am I going each time? Am I going up or down? Well, if you notice here, it looks like I'm going down 3 each time. Well, okay. Since I'm going at a steady downward pace of 3 each time, d becomes -3. Well, alright. Now, notice my first term was a 5. So under my a to the first, my first term, I'll simply put a 5. So far, so good. Since I'm going 22 terms, I'm going to, from my first one to the 22nd one, I'm actually moving 21 spaces. Now, why only 21? Because I already have the first term right here, and I only have to move 21 more to get to number 22. So, you take 22 minus 1, which is 21. So 21 jumps of -3. So 21 times -3, which make -63, plus my initial star of 5 makes -58. Little tricky. Let's see what you can do. Go ahead and erase some of that down here too. So go ahead and do a U try. 2, 8, 14. And we're trying to get to the 12th term. Go ahead. Well, if you had trouble, know that from 2 to 8 is +6. 8 to 14 is +6, and so on. Now, since my increase is +6, I'll put that here for my d. My first number is 2, so you put a 2 here. I'm making 12 jumps, so 12 minus 1 is 11. So I get 11 times 6, which is 66, plus 2 from my beginning. I should get 68. And if you notice, that's what I kind of did up here. I said, okay, well, 12th term minus 1 makes 11 jumps. 6 jumps per, so that goes ahead and gives me 66, and I have to add 2 to begin with. And if I actually wrote them all the way out, I would have 2, 8, 14, 20, 26, 32, 38, 44, 50, 56, 62, 68. If you notice, my 12th term would be 68. Time for a commercial.
You do it.
Bye.
And we're back. So let's go ahead and make this example here. Let's see. That's odd. No. Oh, I was right on that page. Doy. I went backward instead of forward. Whoopsie. Alright then, let's try this one. Now the word problem. Word problem. Ha! But don't worry, we can do it. Yes, we can. That's right. So we have that. Each week, Caitlin earns $37 between allowance and helping neighbors with outside work. If she starts week 1 with $10 and doesn't spend any money, how much will she have by week 5? Well, let's look at the traditional way. You have $10 to begin with, and every week you're getting $37. Well, all right. So week 1 you have $10, but week 2 you added 37. Remember, you're not spending any money, so you add 37 to the 10, you have $47. Add 37 to the 47, in week 3 you have $84. If you add another 37 by week 4, you have $121. Add 37 by week 5, you have $158. So that's a good strategy. But what's the other way? The way we just learned, by the way. Well, if you take a look here, well, we had 10 to begin with, so A to the first, or excuse me, not A to the first, but A1 is $10. We want to get to our 5th week, but we're already on week one, so you have to go 1, 2, 3, 4 more weeks. So we have 4 more weeks, or 5 minus 1, of $37. So you just take 4 times 37, which means we're going to gain $148, plus our 10. Notice that it makes $158. Now, the baby might say, angry baby, hey, why would I use that stupid formula if I could just add 37 4 times? Well, angry baby, because let's change the problem by one thing. Blah, blah, Caitlin earns $37 between allowance and neighbors and everything else. But how much would she have by week 50? Now, I could just add 37 50 times if you like, but that would be a long process. Plus 37, plus 37, plus 37, plus 37, plus 37. So instead, just say, okay, she has $10. She wants to get to week 50, so she has 49 more weeks to go. So 49 times that, 37, which is right here. 1,813. Okay. And now, I take 1,813 plus the $10, and she would have 1,823. All right, good enough. Rewatch the lesson if you need to. Please see me for help in the morning before class if you want to do a few extra practice problems. Remember, 10 points if you write this down and give me the notes. Thanks again. Here's a clip. Take it easy.